Solar power is cleaner than electricity from fossil fuels. Solar power does not lead to any harmful emissions during operation, but the production of the panels leads to some amount of pollution. A 2021 study estimated the carbon footprint of manufacturing monocrystalline panels at 515 grams CO2/kWp in the US and 740 grams CO2/kWp in China, too, but this is expected to fall as manufacturers use more clean electricity and recycled materials. Solar power carries an upfront cost to the environment via production with a carbon payback time of a few years as of 2022, but offers clean energy for the rest of its 30-year lifetime. The life cycle greenhouse gas emissions of solar farms are less than 50 grams g per kilowatt-hour, kWh, but battery storage could be up to 150 grams/kWh. In contrast, a combined cycle gas-fired power plant without carbon capture and storage emits around 500 grams/kWh, and a coal-fired power plant about 1,000 grams/kWh. Similar to all energy sources where their total life cycle emissions are mostly from construction, the switch to low-carbon power in the manufacturing and transportation of solar devices would further reduce carbon emissions. Life cycle surface power density of solar power varies a lot but averages about 7 W/m², compared to about 240 for nuclear power and 480 for gas. However, when the land required for gas extraction and processing is accounted for, gas power is estimated to have not much higher power density than solar. PV requires much larger amounts of land surface to produce the same nominal amount of energy as sources with higher surface power density and capacity factor. According to a 2021 study, obtaining 25 to 80% of electricity from solar farms in their territory by 2050 would require the panels to cover land ranging from 0.5 to 2.8% of the European Union, 0.3 to 1.4% in India, and 1.2 to 5.2% in Japan and South Korea. 3. Occupation of such large areas for PV farms could drive residential opposition as well as lead to deforestation, removal of vegetation, and conversion of farmland. However, some countries, such as South Korea and Japan, use the land for agriculture under PV or floating solar. Worldwide land use has a minimal ecological impact. Land use can be reduced to the level of gas power by installing it on buildings and other built-up areas. Harmful materials are used in the production of solar panels, but generally in small amounts. 4. As of 2022, the environmental impact of perovskite is hard to estimate, but there is some concern that lead may become a problem. A 2021 International Energy Agency study projects the demand for copper will double by 2040. The study cautions that supply needs to increase rapidly to match demand from large-scale deployment of solar and required grid upgrades. More tellurium and indium may also be needed, and recycling may help, as solar panels are sometimes replaced with more efficient panels. Second-hand panels are sometimes reused in developing countries, for example in Africa. Several countries have specific regulations for the recycling of solar panels. Although maintenance cost is already low compared to other energy sources, some academics have called for solar power systems to be designed to be more repairable. As of 2022, over 40% of global polysilicon manufacturing capacity is in Xinjiang and China, 5, which raises concerns about human rights violations, Xinjiang internment camps, as well as supply chain dependency. However, solar cannot be cut off, unlike oil and gas, so can contribute to energy security.